Thanks everyone for attending my talk today. I'll be talking through essentially a tool that we built at Salesforce called Metabadger, and essentially helping to automate IMDS protection at scale across various infrastructure and across your AWS accounts. So a little bit about me. Currently, I'm a security engineer at Salesforce supporting various clouds. As Kimberly mentioned, I work on a lot of different business units, and so we deal with a various amount of problems amongst these different cloud spaces, right? And different challenges across them as well. So it's something that we kind of constantly have to evolve to and adapt to, right? So things are shifting a lot and changing across the board. I really like automation and putting in cloud automation where possible, right? And leveraging public cloud service providers to be able to kind of let a lot of the robots do the work for you rather than doing manual work, and also kind of reducing that extra toil or friction that exists out there. I think that's super important in every security program. It's something that should definitely be kind of top priority for folks. In general, right, shifting left is one thing in particular that I think is super kind of important to me. And I think being able to see where the industry is going and then put controls in place that actually prevent things from happening in the first place is also an area where I'm super interested in. How do we put more preventative mechanisms in place rather than going through and kind of figuring out more manual ways of doing things, right? And so that's kind of where a lot of my interest lies currently, and I think that's a super cool space to be working in. And recently I've been more so involved in building a lot of tooling for making different security infrastructure changes or even automating things within these environments. I also think it's super helpful for enabling engineers to help them and be able to automate a lot of the work that they do to, whether it's remediating vulnerabilities or solving different application security problems, and to be able to apply that across the board there. So today, kind of boiling it down, why are we talking about metadata, and what is it about metadata that essentially gives you, a lot of different, things to consider as far as what you need to look at. The service itself can give you access to the user data, which an instance may use, and also IAM credentials, right? So a lot of the things that you do from a fundamental kind of standpoint of spinning up an EC2 instance, it will usually involve some kind of IAM role to talk to other resources in your account. And from this point, right, and the service that is used for that is the actual instance metadata service, which is abbreviated as IMDS. And the instance role and credentials and tokens as well will be used throughout that to be able to kind of pull data that the instance needs to be able to talk to the resources, as well as kind of understand what its context is and some other kind of pieces as part of this metadata service. And kind of breaking that down even more, right? So why would an attacker want to leverage this, right? Simply said, right, if you can pull the credentials from the metadata service, then we know that, hey, we can now pivot in the environment. And SSRF attacks that are known and kind of have been used in the past, right, to exploit this particular vector, which definitely, can do essentially anything that instance can do, right? So if somebody's to leverage this, they can go through, take a look at your environment, take a look at what this instance can do, and potentially exfil data as well as send it elsewhere. And so we've seen this in the news. A lot of the attacks that you've seen in the news and elsewhere kind of have been essentially this same vector, right? That was used, hey, exfil that metadata service credential or user data or whatever it is that's accessible from that, and now exploit that, give it to me, and I'm going to go and dump a lot of stuff out of your AWS account, which can be really scary when you think about it, because there's a lot of sensitive things that live there. The attackers, right, can just clearly dump their credentials and use them. And so that's one area where like, hey, how do we really mitigate against this? And what can we do to solve this particular problem? So just a high level breakdown of sort of what this attack chain and flow looks like is we have a user that's exploiting an SSRF web app vulnerability that may exist on a web app or some kind of customer facing or user facing form, right, or input field, where they're able to kind of now leverage this and say, hey, I'm going to get access to talk to the instance and talk to what the instance can do from the metadata perspective. Looking into this, right, we can see, hey, we're able to run something now from the web app. The attacker has now kind of understood this, and they'll try usually to see, can we curl the metadata service? Can I go ahead and talk to this particular sensitive service that exists out there, which could help me pull down the credentials, the user data, other sensitive pieces of information that could give away more information about your environment from a reconnaissance perspective, and then get that back and bring that to the actor as well. But so if they're actually successful in getting to the point of curling the metadata service and getting those credentials, they're simply able to make that request where, to the instance itself, it may seem like the instance is just making that request on its own, right? Because it's coming straight from that particular web app that's running on it, right? And so this is looping back, talking to the metadata service. The instance simply returns that through to the web app, grabs it, sends it to the bad actor again. And this is where, at that point, the attacker will now use a secret key, an identification key, or the key, right? And then as well as a session token to say, now can I use these credentials and particularly assume the role, or even use those creds in particular to access anything that instance had access to. And then this is where the pivot vector itself comes from, right? So now they're able to pivot and traverse your environment, take a look at various areas. A lot of discovery work happens at this point in time, right? So if you're looking through and seeing, access to S3 or access to some other resource, they're able to dump those or potentially even modify things depending on what the instance can do. Now, if we look at V2, we can kind of see how this changes a bit, right? So the same exact flow would work in the sense that you would still have the same web app vulnerability that exists. I would go through and take a look at the instance metadata service. We would talk to it. We can go ahead and check, hey, are we able to return this to this request from a curl, or can I even see anything beyond this? And that comes back essentially to the web app. The attacker sees that, finds that, and now it's returned. They're able to say, hey, can I use these credentials and actually talk to different things? And this is the part where really we're creating some extra friction and we're making it harder for attackers to actually look and get these credentials and use them as easily as they could before. So AWS implemented V2 to essentially prevent that particular attack vector and harden that environment as far as being able to exfil those credentials from a VPC or from wherever the instance is running and then use them elsewhere. So we can see that access will be denied, right, if they are getting that, because we're moving from a simple put request model to a session-based model. And what's important to note here is like, hey, now we're going to need a token. And on top of that, there's a couple other pieces around TTL, correct headers, and so forth that we're going to be looking at to really make sure that this request is coming where it's supposed to come from, right? And I think that's a super key indicator to help you determine, hey, now that we're validating this request, you can no longer, take those credentials and use them from anywhere. And I, on a high level, I think it's super fundamental to understand that, if these requests are kind of being made from somewhere where they're not supposed to be, they should never be ever kind of allowed to be made. And you can probably pair that with IAM policies, et cetera, as well. But just this simple flow, right, and changing this one thing on the instance can actually prevent you from dealing with that particular problem. So what are the larger differences in V1 and V2? And I kind of went through some of these. We're really moving away from a simple put request model to the session-based one. And we're asking for that token, right? So anytime you make a request to the metadata service, you're going to have to pass it a token. And so you originally have to essentially get a token first, put that into your request and say, hey, I have a token now. I'm going to pass it to you. I'm coming from a legitimate place, and this request should go through and you can give me back whatever information I'm asking for. The actual token was not a requirement in V1, right? So that was one area where I think has improved over time, and it's kind of why we need to do it this way, as well as kind of changing the different methods, right? So that put request model is changing now, and we have the get and head methods. So anytime you're making a request to the metadata service, we have to, essentially add that to the get method itself and say, hey, we're inserting a token here. And if that token's not there, you're definitely going to get an unauthorized, access denied. You're not passing me the right things I need now, because we're adding a layer of complexity and also preventing this larger pivot vector for attackers to use across the board. So why should we use it, right? And we chatted through that. We emphasize that, hey, it's a session requirement. and really it boils down to the fact that this is really a hardening configuration, right? And you are mitigating a good bit of risk in the sense that a lot of those same attacks that we were talking about are now a lot harder and actually can't even be performed most of the time. And this paired together with SSRF vulnerabilities, I think, tackles a larger problem around how the metadata service itself is being used and how we're actually communicating with it, right? And how attackers will leverage that and play into the whole concept of, hey, I can now steal your credentials because there is no other mitigations in place to prevent me from using them outside of your account. So we really want to make sure that the actual configurations on these hosts are locked down, and that can be done via the API, right? We can make it a requirement every time an instance is spun up. We can also do that via an IAM policy and say any request going to the metadata service itself should be and should always, make sure to be coming from a particular version of that service, right? So if it's, hey, are we talking about V1 or V2? It'll come from V2, and a request from V1 on that particular instance will actually fail. So you won't even be able to use V1 on there, and those will fail. So you're always enforcing it. Session tokens as well, right? So when we're talking about having those enabled and always mandatory, we're restricting it to simply say every single request being made to that service has to have that mandatory token, right? So this is also where it gets complicated because a lot of the existing infrastructure you might be running may not consider this, and we'll get into that a little later, but it's just another kind of step in the process of talking to the service and getting those credentials down. The other larger call out is also the forwarded for header. So a lot of the times attackers may actually use some kind of proxy, right, to route traffic through and actually pass things by, in a sense that when they're going through the web app, they'll try to get to the instance that they're talking to, and this information will get routed back, right? And so what this particular, what the V2 of the service does is actually limits that ability because it'll validate the origination and destination of that particular, that header there to say, are you coming from a place where you're allowed to come from? And if you're using this particular header, we're not even gonna allow this request to happen because you're forwarding this particular request to the metadata service. We don't really want this kind of traffic happening in the first place, right? Because essentially the instance should only be talking to the metadata service at the hypervisor level at the EC2 point of view, right? So there should never be something forwarding a request to the metadata service. And if there was a use case like that, I don't know, outside of some attack scenario, what that would be used for, but there could be. But in this particular scenario, we're kind of vetting out a lot of those particular proxy-based attacks. Tooling wise, right? So when I looked at solving this problem originally, the first thing you usually do is kind of check, hey, is there like a tool that does this already? Is there something out there that can help us and mitigate this problem and solve this particular risk for us in an easy and simple way? And kind of baking that down. I didn't find anything that could really, at the time at least, that was super granular and running this type of attack and being able to sort of hand pick what you wanted to fix and what you wanted to upgrade. There's a number of different things that exist today inside the cloud provider itself in AWS, where you could use some CloudWatch metrics to kind of determine, hey, are we using V1 versus V2? Can we actually track this? And then can we actually look at even the EC2 API, right, to be able to look at, hey, is this instance running which version, right? And so there's a lot of different options that you have that exist today in order to look at this. But at the time, I really wanted to gather some kind of tool that would be able to sort of scale as well, right? So a lot of the times I'm looking at different infrastructure that could have anywhere from like 80,000 plus instances, right? And this could span across multiple regions, right? So we're really looking at a lot of infrastructure, a lot of different running nodes, and this can span across your container infrastructure as well, which could be running on EC2, right? And they also have a metadata service on those. Every single EC2 will. It's just the nature of how the instances communicate up with the rest of the resources in that particular account. But we really wanted to proactively sort of see, hey, are we able to check on what every single instance is using, and then are we able to kind of validate that, right? So in our kind of like brainstorming of the tool, we wanted to be able to add the configuration options in there to be able to harden the infrastructure and then take a look at what we're dealing with from the infrastructure point of view on the instances. The SCPs that exist today as well is another aspect to point out. So you can actually have preventative policies that will be put in place where it says you can't even spin up an instance that is using V2 because our overarching service control policy says that we can't do that. This is a very kind of shift left way of doing it. I know in GCP, there's also kind of policies like that as well. And this is AWS's version. I think they're great once you kind of sort of know that everything in your environment can run V2, but there's a lot of discovery in the process of making sure that you're actually in a place to go ahead and put a policy like that down, because once you do, there could be issues with existing infrastructure. And I know I've mentioned, throughout the slides here that, hey, there's definitely a lot of caution to be had with deploying any of the V2 versus V1, because certain services and certain infrastructure can only run with a particular version, just depending on what it is, because of, like I mentioned earlier, right, we do have to kind of curl to get that token. A lot of things out of the box may not know how to do that. Sometimes we run into cases where things might not know, hey, did you switch versions? Like, is this a session request? Even with the methods of how is it being communicated to, that's another piece of it that gets to kind of come into consideration as well. So mentioning the discovery process earlier, right, we had to go through and take a look at how do we actually determine what is using our metadata service. And by looking at the CloudTrail logs, that's one really good way, I think, to actually find out, hey, are we using the metadata service? And if so, like, where is that coming from? And from our perspective, the real lens of it, right, that we wanted to see is the biggest kind of differentiator there between the two is if we're going through the SDK, we probably know that upgrading to V2 won't be as complicated of a problem, essentially, because it's a lot easier to have V2 going through the SDK, and a lot of the SDK versions actually support V2 out of the box. So you're saying, I don't actually have to go and curl the metadata service, and I'm just going straight through the SDK. It will automatically just use V2 because that's the way it works, right? And if it's on the version that supports that as well, you won't have to run into that issue. The other thing with the user data and the user agent itself, well, the user agent, we could tell if it was coming from a particular CLI command, because Amazon actually will tell you, hey, you're either going from an SDK or somebody's running a command versus with the AWS CLI, which could mean something completely different, which we'd have to put some other scrutiny into, right, to understand how does this work, what does this look like, and so forth. The user data itself is another area that I think is important to look at. So are you calling the user data when you're spinning up your instances? This is also another piece of it, right? Because this is coming from the metadata service. So at any point during the runtime or even while the instance is running, are you looking at pieces of the user data that you're passing to the instance for any kind of purposes? This will also be something that's helpful if you look at the code base itself and of something that's running, and you notice that you're seeing different user data being stored in variables, and you're saying, I need to figure out, like, where should I be processing this, and where are kind of like areas where we need to take a little bit more concern and caution, because there could be situations where V2 will cause problems with that. And I've also kind of evaluated different software, right? So some agents and software that runs on hosts, depending on what it is, and depending on if it's a vendor that you're using or if it's some other open source tool, right? Sometimes they only support one version of IMDS, which is super interesting. And this goes back to the whole concept of, hey, is there a token being used? If not, then that may be the whole issue there around what this particular service is doing and what the agent is doing to be able to kind of work with IMDS correctly. And that will definitely break at some point, which is why, testing is super, super important here. Like, depending on the environment that you're in, if you're in dev or stage, just testing this out and making sure that, once you've updated the IMDS kind of version, you're testing and you're thoroughly kind of going through and making sure that all your unit tests and everything else that your, QA process would hold in place is actually completing as it should be. Just because, you never know when there's one service or something that's leveraging the IMDS kind of larger service that may have a problem or break at some point. And then logs, right? So logs are really, really important as well to look at on actually workloads or instances that you're running as well, to see hey, is there something in here that would tell us that we're actually talking to this particular IP? So we saw earlier, right? We know that it's like 169.254, right? And repeat it again to be able to talk to that. If we're able to see, hey, on the instance itself, are we actually doing anything, or do the logs point to us talking to the metadata service at all? Because this will really tell you what exactly is happening. So any kind of like host-based logs that you're forwarding over, if you can take a look at those and actually get a better understanding of where those live, I think that's super helpful to just know and do more of like an inventory to speak, and then understand where exactly that service lives. And the tool we made was Metabadger, and kind of solves for some of those larger pieces that we just discussed around checking to see which version you're using. And we want to be able to do this at a large amount of scale, give insights into different things like role attachments. Are we using IAM services? And are we, kind of looking at all the different precautions we want to take around that, right? So being able to iterate through every instance, say, oh, are we using IAM here? Is there something in particular we should be looking at? Call out the role, be able to understand that, and then also give us a lot of different options as far as what we're able to do. So we want to have the ability to not only just upgrade to V2, but we want the ability to enable it. Let's say it's turned off somewhere where we need it. Let's say we want to disable the actual service itself or it's not needed. And I think that's actually a really good approach because, if you have an AWS account or something where we're using a bunch of instances and they really have no need for the service, then, you can simply disable it. And that way you're kind of reducing any potential there for if something were to change on that host or whatnot. And so those are the two main functionalities, as well as kind of upgrading, which is the base one, right? From V1 to V2, we do a simple API check. We want to go through, check to see if in that returned object we're seeing V1 on that particular host. If so, we would easily be able to upgrade to V2, right? And this is super simple from the EC2 API to be able to go through and do that. And then, as we're thinking through this, we're also considering, hey, should there be a fallback option? And as always, and in the world of technology, right, you always want to be able to roll back. So we created some functionality there about rolling back and being able to go to V1, as well as kind of logging every change there, and being able to understand, hey, what's being done, right? So we included some things such as like a dry run functionality and so forth to be able to validate what you're doing and making sure that all those potential kind of config changes that you're about to make are documented somewhere and you're able to kind of evaluate that on your own. The other piece that we wanted to kind of also add was around the ability to be super granular. So like when it comes to tagging and other instance IDs, there's always going to be the question of, do we want to apply this across the board, or do we want to single out certain instances or certain workloads where you might not actually want to update the service, right? Like we mentioned earlier, if there was an issue with the software or something else was kind of problematic for you and you wanted to hold off on upgrading certain pieces of your environment, you could do that. And so we added in the component of looking through and having Metabadger go through and evaluate the tags, as well as kind of update instance IDs based off of passing in a file, essentially, to go through and validate and say, okay, these are part of the list of things that I need to go and update. I'll go ahead and do that. So larger, higher picture kind of problem statement, right, that we mentioned is sort of putting in together the piece of kind of, hey, what are we solving for here, right? And how are we kind of approaching this problem, right? And it kind of boils down to you have a bunch of web apps or load balancers or whatever you're serving on these EC2 instances, right, with sensitive data and other things and all sorts of, right, containers, whatever it may be that's running on these EC2s. And if they do have the ability to be susceptible to SSRF attacks where, they could potentially get a foothold on that ability to inject something and then curl back a response from the metadata service, then we're dealing with a larger problem. And so these vulnerabilities could definitely exist across the board. The thing is, we don't really know, right? And our kind of main goal is to reduce that overall attack surface to make sure that that isn't even a problem in the future, right? When we're looking into it, and we shouldn't even have to worry about the fact that a particular SSRF vulnerability is going to cause this issue if we're really looking at a defense in depth sort of approach to it and layering on additional kind of friction for an attacker to have to protect the particular instance that we have. And then, as far as the attack surface goes, we're really kind of limiting the blast radius there as far as what they can do from the credentials, as well as their ability to even get those credentials and move out there. And then back with evaluating and doing the discovery, we want to make sure that everything that we're doing and looking at as far as instances go, we can understand, hey, are these actual kind of like IAM roles that are being attached to these instances? Should we be looking at these? And then also we want to make sure that we're pairing that data with our metadata hardening, right? With the actual tool itself, can we now evaluate everything and give us a better understanding from the discovery process? So today, we have a few things baked into the tool. It is an open source project. It is available today as well. But currently, these are some of the base functionalities that are built into it. So you can easily kind of run Metabadger and go through and discover all the different metadata usage, depending on what version you're on. And then you can do this really at scale, which I think is awesome in the sense that you will, if folks have ever worked with Bodo 3 before, there's definitely some cases where you'll do pagination if you're dealing with really large data sets, et cetera. And at scale, right, you really have to build out your code in a way where it's going to be able to understand, oh, I'm looking at tons and tons and tons of data, tons and tons of instance data as well, because there's so many of them, and being able to parse that out and correctly kind of modify things in a way where that makes sense, and in a way where you're not kind of getting to the API in a way where it's going to kind of throttle you or run into issues of that sort of nature. So that was a huge kind of functionality that the main real functionality we wanted to build out is, hey, can we actually go through and discover all of this and actually go through the hardening process the same way at scale, and being able to build code that functions in that aspect. And on top of that, like I mentioned, the discovery aspect of it is also important. So we wanted to see where the roles were. So we also go through and kind of parse out the roles that are being used per instance, as well as kind of all the functionality around disabling, updating it. If they're not being used, we can actually go through and just disable it. And then we can also just update and harden it across the board. And recently, we even added the functionality to do that across like an entire account. If you wanted to pass in whatever regions you want, or if you wanted to just run the all region flag on there, you could actually go through and just update everything all across the board. And then, once you've done all this work, you should be able to kind of produce a summary of, hey, metrics wise, right? We love security metrics. We love to see, how is my attack surface changed? How many instances are you using one version versus the other? And we're able to break down a percentage essentially of where our problem areas might lie and what percentage of coverage we have for V2 as well. So some future architecture and design kind of goals that we have on here in a wish list as well is just kind of including functionality for some automation, right? So we really wanted to build in and potentially even build in some Lambdas that could do some auto enforcement. I know part of this already exists with some config rules, but we were thinking of, hey, if we wanted to kind of increase the automation behind Metabadger and have this running as a continuous enforcement thing with those same kind of mechanisms that you wanted to pass through the tool, we find that that might be helpful for folks, right? So being able to update things like tags or instance IDs or other kind of pieces and components of it would be super helpful to have that running in a continuous enforcement environment, because then you can get granular and you can have your automation kind of work for you in that sense. And then, moving back to the shift left concept as well, we wanted the tool in the future potentially to look at the different kind of configurations that may already exist out there. So if you have a code base where you're checking an infrastructure as code such as CloudFormation or even Terraform and others and so forth, right? How do we actually look at that? How do we look at the code that's used to actually spin up the infrastructure and even go through and call that out in the code base? So maybe we go through and check all the different Terraform modules or validate anything that might be spinning up an EC2, right? To see, hey, are we actually using V1 or V2 here? Are there any provisions that we're putting into place there around like validating that folks can't just use the default version, et cetera, and then building that into the tool to be able to validate that or even update it, right? So going in there and like maybe even adding in a config change to update your kind of metadata service to V2 is something that we've thought about. And then in AWS, I know that there's an option for V1 and V2, and some other cloud providers that may or may not work differently, right? So some of them enforce them being on the latest by default, others don't. It's just kind of variant depending on the cloud, but we find that there may be some usage here around how the service in particular across the board, across cloud providers is being used. So, if this tool would be beneficial in that aspect, we may kind of span it out to at least do some of the discovery work or even hardening work across the board there. So this is a quick demo. I can kind of show you how the tool itself functions. We walk through and do just a simple kind of Metabadger discover metadata, right? So this goes through and pulls down all the different instances where you have that are enabled or optional. Essentially optional just means, hey, you can use V2. You can use V1 because V2 is totally optional. And this is coming straight from the API. So that's kind of like the language that's used there. And then we also get a breakdown of which ones are enabled and then a total instant count. So we can see how, what our percentage of enforcement is. That second command there is a discover role usage one where, like I mentioned, right, being able to identify, hey, which instances have a role attached? Can we parse that down? Can we actually take a look there? This is just good for, doing a little bit of initial reconnaissance to see, is IAM being used? Is it kind of in play here? Do we need to take extra caution? And finally, hardened metadata kind of goes through, and we'll just do a default on US West 2 to iterate through every single instance and update that. And so this is just the super base functionality. Obviously, there's a lot of flags and things you can pass in, like I mentioned. That's kind of on our actual repos as well if you want to read into it. But that is sort of a gist of what we kind of built out in a quick little demo of how that all works. Let me go ahead and present back. So yeah, onto the next slide here. I just wanted to give a quick kind of moment to call out that we are hiring here at Salesforce. A few different roles and role types, I guess you could say, as well that we're hiring for. So as far as the security architecture goes, DevSecOps, so a lot of the work that things like Metabadger, et cetera, and then kind of working on that within the environment as well. Threat vulnerability management, pen testing, and then recently just enterprise security just came up as well. So if you have any interest at all, if you want to chat through it, or if you want me to connect you with the right folks, feel free to DM me at on Twitter. And then I'm also in this really, really cool Slack channel as well called Cloud Security Forum. So folks join that. Some folks that I know, as well as some other interesting folks in this space who are always kind of solving the next kind of larger problems that exist, which is always involving right in cloud security. So feel free to connect on there. And yeah, so this is a reference to the actual repo itself. And we really love contributing with folks in the community. So if you have any ideas or feel like there's some contributions that could be made as well, or even just questions, feel free to reach out. Super happy to help and super happy to hear also like experiences with using the tool and how it looks in them and other people's environments, as well as if there's any issues with it at all. Yeah, I guess we're good to go to Q&A.